Imagine a submarine equipped with a basic AI designed to differentiate between mines and rocks. It accomplishes this by using active sonar, meaning it emits a pulse of sound, and if the sound bounces back, we know that something is up ahead. But just knowing that something is up ahead is not sufficient for our purpose. The task is to know whether it is a rock or a mine we're facing. Now let's say the sonar has recognized that something is up ahead. The sonar signal can be divided into 3 parts: low, medium, and high frequencies. All of these frequencies within each echo vary in volume. Now, let's say that we've received 3 numbers from the sonar: 9, 1, 3. 9 represent the amount of volume in the low frequency, 1 the medium, and 3 in the high. Now, just by looking at these numbers, we cannot know whether we're facing a rock or a mine, so we need to feed these numbers into a connectionist system. Here is a very basic connectionist system. It consists of 3 different layers of nodes. The first is the input layer, second, what is called the hidden layer, and thirdly, the output layer. The input layers represent our 3 parameters, the volume of the low, medium, and high frequencies. The output layer represents the result. The left node represents a mine, while the right node represents a rock. We then insert these numbers we received from the sonar into the input layer, which activates the nodes in various degrees. Each node in the input layer is connected to the hidden layer, and depending on how much the connections are weighted, so to say, the hidden nodes will become active in various degrees. Let's say we put a weight of 0.5 between this input node and this hidden node. Here, the activation of the input node is 9, and what determines the activation of the hidden node is the activation of the input node multiplied by the weight of the connection, which is, like I said, 0.5. So at first, this node gains an activation of 4.5. But this hidden node is also connected to the other input nodes as well. So let's say that we have a weight of 1 here and a weight of 0.2 here. After the math is done, we have a total activation of this node of 6.1. How this hidden node in turn responds to its total activation is determined by a mathematical formula, which we don't have to get into here. But quite often, if a node does not surpass a certain threshold, it won't get activated at all. This procedure occurs between each input and hidden node. Then the same process of different connection weights is done between the hidden nodes and the output nodes. In the end, depending upon which output node that possesses the highest amount of activation, determines whether the system believes the sonar numbers represent a mine or a rock. So now we have the system ready for training. In order to proceed, we need a huge data set in which we know each answer. Here we know it is a rock, and let's say the sonar gives us the number of 3, 5, and 2. We then feed these numbers into the system and see how it responds. Here, the system thinks it is a mine, which is false. So the system made a mistake. A common way of fixing the system's mistake is done through what is called backpropagation. Roughly put, we need to trace the error from the output layer back to the input and adjust the weights until we have the correct result. This can be done manually, which is very tedious, I believe, but within modern systems we can use mathematics to correct it. This procedure is done through the whole dataset, and in time, after a number of fine adjustments of the weights, the system will be able to distinguish with great accuracy whether the sonar signal represents a mine or a rock.